Real quick, I work for a company named Tabula, which is working on a new generation of field programmable gate arrays. And I manage the software team for the synthesis engine there, so I'm still heavily involved in the development of technology using standards in that job. And I'm also the technical chair at Accellera, which means that I'm responsible for helping all of the committees that are actively developing technology under the Accellera umbrella, helping them to get their standards out and to interact with the board for getting approval of those standards. So, what are standards? A standard is an established norm and a formal document that says, what does this technology mean? How does it work? How does it share data? And it creates a common platform among a collection of users who choose to agree with the standard. It's not a custom. In the case of the synthesizable subset of Verilog, for example, Synopsys owns an informal standard by having design compiler. There's no formal standard that everyone has to follow for synthesis, for example. So there's a difference between an agreement among a large body of people, both users and providers, and a particular provider that kind of has an effective monopoly over the definition of something. Why are standards important? Standards fuel compatibility and interoperability. If you've got a standard everybody shares, it becomes possible for innovation to happen in places around the agreement so that you can bring new tools to the place where the standard defines something. They make it easier to understand products and compare products. It makes it possible for you to swap a product in and out. You can use a simulator from one of many different companies that are available today and swap them in and out. You can trade price. So there is innovation that happens on the speed of the simulator, the memory of the simulator, or so on. But the standard gives you an ability to let innovation happen in a number of places rather than having innovation end up frozen in any particular place. Let's see. So, the importance of standards and why are they important? Craig Barrett has said that when you have common interfaces and common protocols, everyone can innovate and interoperate. Companies can build their businesses, consumers can expand their choices, technology moves forward faster, and users get more benefit. Having a standard benefits the entire community, not only within EDA, but beyond it, because we're able to build better products, we're able to build them faster, folks are able to innovate and add new ideas and new contributions around the standard. It also makes it possible to play even internationally, so that things that we make here can work in China and things that we can work in China can work here. I can offer that, having traveled to Europe and overseas several times, going and having to figure out what plug I need to go plug into the wall. It'd be really nice if there was one plug that worked on the whole planet, rather than having to buy these things that change among the various plugs in the wall. So, we've talked a little bit about standards benefiting the world. How does standards benefit the people who work in the standards body itself? In the case of users of the standard, it makes it possible for a user to drive into a standard something that you want across multiple tools. For example, Intel came to the 1800 standard and drove the addition of assertions and the way assertions work in the context of that language so that it could work in their simulators, it could work in the synthesis tools, it could work across the broad suite of what is this language. It could also work within the context of synthesis across multiple vendors. So it gives you, as a user who has a problem you need to solve, a way to drive a solution into that problem across the industry. In the case of vendors, it gives them the possibility to influence new directions that are happening. A customer says, I got a problem, I got to solve it. The vendors will come and look at the problem and go, oh, if we solve it this way, it's easy for me to implement. And if we solve it this way, it's not so easy for implementing. And so the vendors want to come to standards to influence the direction in the implementation to their benefit. Now, for the engineers involved, not necessarily playing corporate politics one way or the other, they get to influence the technical problems that they focus on. If the standard only had this defined, if the standard only had this little piece of functionality, my job would be easier. So it becomes possible as an engineer interacting in a standards body to change what's implemented to allow you to get what you want to done, what your vision is about how the standard could happen and how it could go into the standard. It gives you a layer of control that if you just let it happen to you, you don't have otherwise. Another advantage for engineers participating in standards is that they gain industry-wide visibility. I have been asked on numerous occasions to write letters for promotions for folks to distinguished engineer. There are several companies that require external to the company visibility for being able to get that promotion, and this is one avenue for doing that. I've had one engineer who wanted to emigrate to the United States. He did not want to do it through an H-1B. He wanted to do it through an O-1 visa. He needed to prove that his interactions made a difference across an industry, and he was a world leader in order to be able to emigrate to the United States. And I have actually written one of those letters to help him immigrate into the United States. It also helps in finding a new job, because all of a sudden you go from knowing all the people local here to knowing people at all the different companies that are around and participating in the standard. So I think as an individual, it makes a big difference to participate in standards and spend energy and effort that way. What's my standard development history? I started in 1995 as a member of the IEEE 1364 Verilog Committee. By 1999, I became chair of the errata committee, so every time somebody didn't like the spelling of a word or somebody didn't like a comma here or there, I fixed it. At that point, what you were seeing was a proliferation of design languages. We had Verilog, we had VHDL, we had EDIF, we had all of these different languages going on. And the fact that there were all of these different languages meant that tools couldn't compete and forced us in a drive to interoperability among these languages. By 2002, I was asked to be the co-chair of the SVBC. This is the basic core language, sort of the Verilog subset of SystemVerilog. And then in 2004, it moved back into the IEEE, and in 2006, I became chair of the working group. Through this time frame, what you saw was a proliferation of verification languages. There was E, there was a number of different assertion standards, and it became important in the user community to move that to one standard language so that they could focus their efforts and reuse them across tools, across projects, sell them across companies. By 2010, I became chair of Accellera, which at that time had 5 individual companies and had a number of standards working with the IEEE. At that point, you began to see a proliferation of verification and specification methodologies, another layer up in the abstraction. How do I do verification? And that drove development of UVM eventually, was one of the standards that arose out of that technology. Today, Accellera has 8 general committees, 5 System C committees, and 9 IEEE committees that we have directly influenced the creation of, and we influence what's happening in those committees as they're developed. What we're seeing now is standards coming out that talk about how do standards interoperate. How do we do, we've got UVM, we've got the multi-language committee. How do you do UVM across multiple languages? So again, the layer of abstraction is going up. So I think as we continue to look forward, we're going to see standardization as we understand how to implement a technology and we're ready to move up the next level. So I think this process will continue. What's happened in terms of the industry for 1800 as it's come along? Before the IEEE, there was Verilog International, which we mentioned in the last talk, that created an open standard for industry adoption. Verilog had been owned by a company that eventually became part of Cadence. And opening it up for this industry adoption all of a sudden meant a lot of new tools, a lot of new implementations. When Cadence had it, it was an interpreted language. It wasn't a compiled language. And chronologic simulation came along and built a compiled language simulator for it, and all of a sudden the performance improved. That innovation became possible because it was standardized. That innovation was given to us because of the interoperability. Once the IEEE approved it, it's also moved beyond the IEEE to the IEC, which is an international standardization body. Before standardization, we had a small number of customers supporting it, and now we've sort of stopped tracking it in 2007 because it's clearly become a very successful standard with a very big community around it. We've got 137 companies producing more than 350 products on SystemVerilog. Standards make a difference. Go there. So, next question. How does one influence a standard if one's an engineer and wants to work on it? Standards are like a rope. You can't push it. You can pull it, but you can't push it. Proposals always influence direction. The more concrete a proposal is, the more influence it's going to have. It's easier to influence a committee to move than it is to influence a committee to stop. And there's a lot of power in the pen. So if you write the proposal, you've got a lot of power because you're writing down the proposal, and people will vote for it or against it. If you want to interact successfully with a standards body, it's important that you participate. It's important that you propose ideas. It's important that you work with others to get support. The more support you've got, the more likely you're able to influence a standard to go in the direction that you want it to happen. I will offer strong support by one vendor will bring other vendors to the table because they're going to have to implement whatever the first vendor had. Okay? And they want to work to ensure that it's a level playing field among all the vendors. Also, vendors will come to the table because they want to protect their current customers and how they're working. If you want to really influence it, again, power of the pen, volunteer, write it down. Keep a close eye on deadlines, because if your proposal isn't accepted by the deadline for the standard, it won't make it. And be aware of the process requirements. They protect everyone. This is like the reading of the IEEE patent policy at the beginning of every meeting. It means that nobody's going to be taken to court over monopoly pricing and IP ownership and all of that stuff. So it's there to protect you. Okay? The next problem with a standard, once you've got it standardized and you've driven it through all the process and the IEEE blesses it, next problem is you've got to deploy it. A piece of deploying it is building a community around the standard that supports it. That gives you the interoperability. That gives you the ability to innovate. And that's important. So you have to keep working once the standard's improved to get it rolled out into the customer bases and customers using it, and to get it rolled out into the provider bases and getting more tools and more innovation happening around it. So if you've got a standard and it's been approved, vendors will choose which parts of a standard to implement in which order. For example, there's a piece of the SystemVerilog standard having to do with case statements and pattern matching that not all vendors have supported, and that's been in the language for 5 or 6 years. So it is possible to get stuff in and not get it implemented. So it's very important that if you want something to happen, you influence not only the standard definition, but also the vendors to support it. Large customers can significantly influence the development pace. Vendor competition can drive implementation. They've got it, they don't. Public comparison of feature implementation can drive implementation. I've seen cases where people have come to conferences and presented comparison papers. This one's got this language feature, this one doesn't. And that moves the speed at which things get implemented. Publicity can drive adoption in the user base. conferences with tutorials, successful use cases demonstrated. When a critical mass of vendors and tools support a standard, it can really take off, as you saw with SystemVerilog in the last slide. The final thing about standards deployment, sometimes in working in a standard, when it's finished, and that process from when you think you're done to when you're finished is about a year in the IEEE. The engineers will want to start again immediately. The problem is that if you don't allow this standards deployment to happen and you don't allow the industry to catch up and the users to use it, then adding a new standard just adds to the, well, I don't have to implement anything because it's not a standard yet and I don't know what's going to change. I don't have to use it yet because it's going to change and there might be some better way to do this, so I'll just sit on it and wait a little while. So it really is important to consider when you're developing a standard, what is the right time to go ahead? When is the industry ready from the current deployment to move ahead to the next one? Accellera has been very, very active, as I mentioned before, in the delivery of, in the creation of standards, sometimes the enhancement of standards and moving them back to the IEEE. We've been involved in VHDL, Verilog. It turns out that Verilog International became several other organizations and eventually became the Accellera Systems Initiative. System C, IP Exact, the standard for electric design intellectual property quality, IP encryption, SystemVerilog, UPF, PSL, they all came out of Accellera. So we have a long history of developing standards quickly because from when the committee is done to when it's declared a standard is more like 6 weeks, whereas in the IEEE, that's about a year. It makes a difference if you want to rev a standard a few times and let people try to develop it as the standard revs. But once it's reached a certain critical mass, it's time to move it to the IEEE so it gets a larger mass of support and credibility behind it, and it can then move on to the IEC and become a true international standard. Accellera provides a number of standards, 1685, 1666, 1801, and 1800, for free for users to download. So Accellera pays an upfront amount of money so that users can get these standards for free, and the IEEE still gets the support it needs to be able to fund the standardization process. And as you can see, with the SystemVerilog standard on the right, it makes a massive difference, the amount of downloads and the amount that the users can look at, use the standard, and develop it. So again, this is a way that Accellera is supporting the community and the broader deployment of the standard. The cumulative downloads for EDA standards has been growing steadily and continues to do so. So I'm very delighted to be a part of an organization that can provide this availability for the industry. Last slide, blatant plug. The IEEE SystemVerilog is meeting on Tuesday at 9 a.m. This will be the first meeting that we've had in about a year and a half or 2 years. It will be the meeting where we start to ask the question, have we waited long enough for SystemVerilog's this definition to settle, and do we want to start thinking about the next one, or do we want to wait a little bit longer? Accellera and IEEE committees are always looking for new participants. Please take this opportunity to influence your future and the industry. There's more information on the Accellera website, or you can always see me.